big thing that people miss a lot is the difference between temperature and heat. So this is a video about heat. So first, heat we are going to define as a transfer of energy, which means it sounds a whole lot like work. It's a little bit broader of a term than work, so let's look at that difference too. Heat, we give a letter Q, and because it's a transfer of energy, it's going to have units of energy, so we are still working in joules. If we give heat to a system, that system can use that heat in two different ways. It can either use it as work, or anything that it doesn't use as work, it has to hold on to. So, work or just a change in internal energy. When we get back to the individual laws of thermodynamics, this is actually a statement of the first law anyway, but what this is saying is that somehow or other, heat is the total energy you put into a system. That system can choose to use it to do something or just hold on to it, but that's what's going on. The reason we mix up heat and temperature a lot is because temperature is a state variable, which means we can measure it right now. Temperature is something that an object has. Heat is a process variable. We can't measure that right now. It's how much energy something is giving off. If I take a pool and I fill it with water, and maybe this water is 85 degrees Fahrenheit, that is a warm pool. If I jump into that water, it's a deep pool, I guess. If I jump into that water is going to feel pretty good. It's going to feel quite warm. If before that I was sitting in a hot tub, so if a moment previous I was sitting in a hot tub, just kind of relaxing, and then from there I go and jump into this pool. Now suddenly this pool feels really cold. What I feel isn't the temperature. What I feel is a heat exchange. When my body is at a warmer temperature, when my body is used to a warmer temperature and I get into something colder, more heat comes from my body into that water. So because my body is giving up more energy, it feels colder. That heat can go into a couple of different things. One of them is just changing temperature. One of them is causing something to evaporate. If I've got a glass of water and I sit here with a hairdryer, I have never tried drying a hairdryer before. I realize. I sit here with a hairdryer, then this water is going to start to evaporate. This is the same thing that happens if you are maybe running outside and you start sweating, right? Your body is putting that water on your surface, on your arms, and as that water evaporates, that takes heat from your body and then uses it to make the water evaporate. Because it takes heat from your body is left with a little bit less energy than it had, and so it cools down. If you go and use a hand dryer, like in a public restroom, right? They have these blow dryers. And there's like some party that wants to wonder, at some point they've got to be able to make one of these that gets warm right away. By the time it's warm, my hands are about dry. There's no point. And that's actually exactly the point. There are these water droplets on your hands. This air is hot right from the start. It really is. If you take a dry part of your arm or something, if you put your elbow underneath that blow dryer, you'll find that it's quite warm right away. But the heat from the air is transferred into those water droplets. Those water droplets evaporate, so you don't feel how warm this is, because that energy is going into evaporating those water droplets. Once those water droplets evaporate and your hands are reasonably dry, now more of that hot air is going straight through, not encountering water along the way, and so now you feel how warm that is. When we do anything with heat, we say that our unit of energy is a joule. Now, a joule you can define as a Newton times a meter. We have a separate unit that we use sometimes called a calorie. A calorie, or cal, lowercase cal. 1 calorie is worth 4.186 joules. A calorie is how much energy it takes to raise 1 gram of water by 1 degree Celsius. When we look at a food label has on the back maybe like 220 calories, and it's a capital C. This we can call a food calorie, and we do call it a food calorie sometimes. A food calorie equals 1 kilocalorie, so it is 1,000 calories. If you are making these conversions, that's how we make them. So this is how much energy it takes to raise 1 kilogram of water by 1 degree Celsius. So then maybe I want to take that 220 kilocalories and find out how many joules this is. So I'm going to go 220 kilocalories. I know there are 1,000 regular calories in 1 capital C calorie. 4.186 joules in 1 regular calorie, and I get 929.20. Or about 921 kilojoules. That's an example, and that's the whole process, really.